Bismillahirrahmanirrahim. Here is the second lecture on the topic of integration. Here we will discuss some short question about integration. The first question is write down the indefinite integral of 0 and square root x. First of all, we will find the integration of 0. To find the integration of 0, apply the operator of integration on 0, that is I is equal to integral 0 dx. Now we can take 0 as a constant outside the integral and find the integration of 1 dx. As we know that and discussed earlier that the integration of 1 is equal to x, so put the value of integral 1 dx and we have 0 dot x plus c. Dot is written instead of multiplication, so 0 into x is equal to 0 plus c, which is equal to c, and in this way we can see that the integration of 0 is equal to constant. C is any constant, you can write any other constant instead of c right here. Similarly, we will discuss another question, square root x, and apply the operator of integration on this question. Here we will put the value of square root, which is equal to 1 by 2 instead of square root. After writing this value, we can integrate. Now we have x raised to power 1 by 2 into 1 dx. Here 1 is the derivative of x, as we have the derivative of x. So we can use this formula. X raised to power n dx is equal to x raised to power n plus 1 or n plus 1 plus c. By applying this formula on this question, we will have x raised to power 1 by 2 plus 1 upon 1 by 2 plus 1 plus c. Now simplify 1 by 2 plus 1 by using LCM technique. So we can get x raised to power 3 by 2 upon 3 by 2 plus c. Again, by further simplification, we will get 2 by 3 x raised to power 3 by 2 plus c. Here we have some few questions. We will find the integration of 1 plus x over x, and we want to know the integration of x square minus 1 upon x square plus 1. Both questions have same techniques, but there is a little bit difference. Like this is an linear algebraic equation and this question is about quadratic algebraic expression. When we use algebraic expressions in integration, first of all we have to check that either this algebraic expression is in proper fraction or improper fraction. If it is in improper fraction, we will solve directly, and if it is in the form of improper fraction, we can further solve and then apply the techniques of integration on it. Here are two questions and both questions are in the form of improper fraction. So first of all we will convert these questions into proper fraction and then apply the techniques of integration to convert in proper fraction. We will use the method of long division. By using method of long division, we can get this expression in the form of 1 plus 1 over x. First method of long division is you can put 1 plus x inside the division and divide on x. After dividing on x, you can get this expression as 1 plus 1 over x. Similarly, you can use another technique which is like you can divide x separately on 1 and x, and you can get the result 1 plus 1 by x. Now apply the operator of integration on this question, 1 plus 1 by x dx, and separately or individually you can integrate both expressions, integral 1 dx plus integral 1 upon x dx. As we learned earlier that the integral of 1 is equal to x plus integral of 1 upon x is equal to natural log of x plus constant of integration c. Similarly, the other question x square minus 1 upon x square plus 1 is in the form of improper fraction. So you can convert this question into proper fraction by applying the techniques of integration on it, and after dividing we will get this expression as 1 minus 2 upon x square plus 1. Now apply the operator of integration on it, and we will get 1 minus 2 upon x square plus 1 dx. Now apply integration separately on both expressions, and we will get this. Integration of 1 is equal to x minus 2, and by using formulas of integration, we have a formula number 17, which is equal to 1 upon x square plus 1 is equal to tan inverse x plus c. And this formula is originally can be written as integral 1 upon a square plus x square dx. A is any constant, and the result of this expression is as 1 upon a tan inverse x over a. Now here are some trigonometric expressions for integration. Here are question number 5, 6, 7, 8. To solve these questions, one thing should keep in mind that the integral of sin x, cos x, tan x, cot x, secant x, and cosecant x can be found directly, as these expressions are linear, or you can say these expressions has a singular power, like these expressions have power as 1. But if we have these expressions in quadratic form, like sin square x, cos square x, tan square x, secant cot square x, secant square x, and cosecant square x, we should keep in mind that we will not integrate these expressions directly. Sorry, these four expressions directly. We can directly integrate only secant square x or cosecant square x, but we will not integrate these four expressions directly. To solve these expressions, we will uh, put formulas instead of these expressions, like we can change sin square x as 1 minus cos 2x over 2, and then apply the techniques of integration. Similarly, cos square x can be converted into 1 plus cos 2x upon 2. Tan square x uh, can be written as secant square x minus 1, and cot square x can be written as cosecant square x minus 1. After substituting these values instead of above expressions, we will able to solve these expressions and apply the techniques of integration on them directly. Like we have question number 5 and 6. Uh, Integral cot square x dx. Now here we are not able to solve this question directly. So to solve this question, we should convert cot square x into cosecant square x minus 1 dx, and then separately solve these both expressions. Cosecant square x is equal to minus cosecant x cot x minus 1 is equal to x plus c. Now this is the way to solve quadratic trigonometric functions. Similarly, we have in question number 7 and 8 cos square x and sin square x. Here we will solve question number 7, which is equal to cos square x dx. Now convert cos square x into 1 plus cos 2x over 2 dx. Now give the value of 2, which is in a denominator, as 1 by 2 plus cos 2x over 2 dx. Now integrate separately both terms. 1 by 2 uh, 1 dx plus constant 1 by 2 into integral cos 2x dx. 1 by 2 integral of 1 is equal to x plus 1 by 2 integral of cos 2x sin 2x over 2 plus c. Here we will not discuss too much uh, on as we will discuss these questions earlier in my previous lectures. That's why we will put less effort on these questions. Simplify this, we can get x by 2 plus sine 2x upon 2 2s of 4 plus c.